All right, so where we left off was this problem, right? We had gotten the equation or the formula, whatever you want to think of it, to answer it. We just need to answer it, okay? So just to kind of go over kind of what we were talking about with this problem. So we have water going into a tank, water coming out of a tank, water being in a tank, right? So at the start of the adding water and subtracting water, there was 150 liters in there, okay? And then they started pumping water in, started pumping water out, okay? They gave us the rate of water being pumped in, but remember, they didn't give us the rate of the water being pumped out. They actually gave us the total. So that's why we didn't have to do the integral for P, because they already did the integral part, right? So that's why. So we got 150, because that was what to start there, plus the total water being pumped in, minus this guy is the total. P of T is the total. We don't have to do integral for P of T, because that was the total. We only have to do integral if it's a rate, and we need to find total, okay? Okay, so last thing. What is the total amount at time 11? So what is the total amount of water in the tank at time 11? So last thing, plug in 11 for T. Everywhere there's a T, you're going to plug in 11, okay? So everywhere, we're going to use the calculator, but this is essentially what we're doing. So 150 plus the integral from 0 to 11 for G of T. That's the only place we don't put T, because we're using this is the only place we don't put 11, because we're integrating that. And then minus P of 11. Okay, so that's what we got to do using the calculator. Well, 150 is just 150. We don't have to do anything to 150. So let's go to the calculator now. Okay. Okay. All right. So we got 150, right? So we're going to go 150 plus, and then we have an integral, right? We have an integral. So integrals are in the toolbox. Toolbox is right below OK, the OK button. Then we're going to go to calculus. We want the integral. This one's going to be 0 to 11. So 0. I can't put G of T because the calculator doesn't know what G of T is, so I have to actually input G of T. Okay? G of T is -2, parentheses, 1.21 to the T power plus 18. Okay. And then you can add, or you can, so what I usually do is I do that first. I don't like to put too many things in. You can. The calculator is able to do it, but I just like to put 2 at a time. So I'm going to do that first. This is not going to be my total answer. This is just going to be 150 plus the integral, okay? And then I got to subtract P of T. All right, so that's that so far. Okay, so then what I'm going to do is I'm going to hit that button at the bottom right that says answer. That's my previous answer. That's my previous answer, because I want to take that answer and I'm going to subtract P of T. Or P of 11, sorry, P of 11. So I'm going to use P, except I'm going to plug in 11 where T is. So P on your notes is negative 154, parentheses, 0.89, parentheses, to the T power. This is where I'm going to plug in 11. And then plus 154. close parentheses. So I'm subtracting that. Okay. So you see when I hit previous answer, it gave me all that stuff because that was my previous answer, minus P of t, P of 11, sorry. And I got 161.821. 161.821. Okay? Yep.
I got a different answer from that. Mine said undefined.
See, that's where I'm saying you got to be careful with the subtractions and the minuses and everything like that. It's probably some sort of error, syntax error, something like that.
It looks the exact same as yours.
Well, I got your answer.
Yeah, that's what I'm saying. So like that one, it's probably something in there that I don't have time to go over every single calculator to look at it, but more practice will help. So just for right now, hang off. But yeah, more practice will help. Okay? That's why we're using the calculators now, so that when we take the test, you guys won't have that issue. But yeah, so right now I won't. So tomorrow when we do the practice, I'll be able to walk around and help you with calculator stuff. But for right now, just so that we can get the unit or the notes done, that's it. 161.821. Okay? All right, so let's go back to ours. 161. And then what units go with it? So it's not a rate. It's not a rate, it's just liters. It's just going to be liters. Yeah, so when it says total amount, it's just the quantity. The quantity is liters. You don't have to square it or anything because it's not area. Liters is already cubed, kind of. Liters is like kind of, so you don't have to like cube it or anything. I know it's a tank, so that's how many liters are in there, right? Okay. All right, so we got one more and then we'll be done. One more, so let's go back to the graphing problem. So this one, example number 4, is exactly like the ones you've been doing. Nothing different. The only difference, I should say, is it gives you a graph instead of P of t, R of t, S of t. We're used to giving rates, right? Well, this is a rate. It's velocity. You can tell. It's time and velocity. Velocity is a rate. So they are giving you rate. They're just giving it to you as a picture instead of an equation. Okay? So Karen rides her bike. So Karen's riding her bike along a straight road from home to school. Okay, she's going from home to school. Starting at time 0 minutes, and arriving at school at time 12. So it takes her 12 minutes to get to school. Okay? During the time interval 0 to 12, her velocity in miles per minute is modeled by the piecewise. So they say it's a piecewise because it's a bunch of lines. It's a line segment, line segment, line segment, right? Pieced together. So we have to use that to answer the questions. Okay, so find the acceleration of her bike at time 7.5 minutes. Okay, so let's go find her at 7.5 minutes. So at 7.5 minutes, she was right about here, yeah, about 7.25. So that guy right there is 7.5 comma 2.5, right? That dot, that red dot.
It's 0.25.
0.25, sorry. You're right. Okay. What was her acceleration?
The derivative?
There you go, right? So a lot of people say, oh, 0.25, that's it. Well, no, because that's her velocity. If it asked for her velocity at 7.5 minutes, I would say, yeah, 0.25, you're done, move on. But this one's asking for the acceleration. Acceleration is derivative of this guy. So it's actually asking for the derivative at the red dot. So how do I find derivative of the red dot? Slope, right? Slope at the red dot. That's essentially what they're asking. It's part of this little thing. Yeah, so you go, it's part of this little segment here, right? And for this segment, I go down a unit, over a unit, right? I go down a unit, over a unit. There you go. So it's going to be, so that your little yellow segment there goes down 1. Well, the y's aren't one whole, they're 0.1, right? So if I go down 1, so if I go down 1 unit, I'm not going down a full unit, right? So acceleration at 7.5, I'm going down 1/10 of a unit, right? Velocity-wise, I'm going down 1. All right? And then I go over 1. Well, that's time, minutes, right? So 1 minute. I should probably put, this is minutes, miles per minute. Anytime you divide by +1, you're just going to get whatever's on top. So acceleration is negative 0.1. What is the units, though?
Miles?
It's acceleration, so miles. There you go. Acceleration is distance over time squared. Velocity is distance over time. Position is just distance. Okay. So what does that mean that her acceleration is negative? What does that mean? She's slowing down. Yeah, she's slowing down. Her velocity is slowing down. Okay, for whatever reason, she's slowing down. Okay. All right, let's go to B now. So B, they want us to do 2 things. They want us to tell what's the meaning of this and find this. Well, this guy looks familiar. This guy looks familiar. Where did we see them before? The speed, but where in the notes have we seen it, right? It's speed. It's definitely integral of speed. What is that? Where did we see it in the notes? We saw it at the very beginning, right? Distance traveled, right? Or displacement. Or sorry, yeah, distance traveled, right here, the one in the middle of the table. It's distance traveled, right? So it's going to tell us what her total distance traveled was. Okay? That's going to tell us what her total distance traveled was. All right, so let's go back. So the meaning is total distance or total distance traveled. All right, that's from our notes. Now we actually have to find this guy. That we're going to use our calculator for. Or we're actually not going to use calculator on this one because we don't have anything to plug in. We don't know what V of t is. The only thing I know about V of t is that graph. So if I'm finding the integral of this graph, what does that mean? Area under the curve. So I know how to do area under the curve, but what effect are the bars going to have?
It's not going to be a negative value.
Everything that's negative, make it positive, yeah. So let's find area under the curve and make everything positive. So we're going to have this area here, right?
+2.
And then this area is positive. Right? This area is negative, but we're going to make it positive because it's absolute value, right? So let's start finding area. Let's see, this guy here, so it's not a full unit, so it's 2 times 0.2, which is 0.4, divided by 2, 0.2. And this is also 0.2. Base times height divided by 2. This guy I'm going to break up into some littler, smaller pieces. There's a triangle there. There's a... Okay. Break up into smaller pieces. You can use the calculator to figure out what each of those is. Right? So just for the sake of time, I did those. Let's see, this is going to be 0.15. This is going to be 0.3. This is going to be, oh wait, I did this. So what I did, oh, this is going to be 2.5, sorry. 2.5, that's a trapezoid. And then this guy right here is 0.6, that's the rectangle.
It's not 0.25?
Yes, 0.25, sorry, yeah. Yeah, no, you're right. 0.25, thank you, yeah, that trapezoid's 0.25. We've done that before many times, so I'm just gonna, if you need to, you guys can figure that out, but yeah. So because this is absolute value, we gotta make them all positive, even though that one on the bottom, that is supposed to be negative, okay? So when we add them all together, I get 1.8. 1.8. What is the units going to be?
Minutes or
Miles,
miles?
yeah. Because we're finding total distance, right? So it's going to be miles. Okay. All right. Okay, so we got two more that deal with this same picture. Okay, so we might have to flip back and forth a little bit. So letter C. Shortly after leaving, Karen realizes she left her calculus homework at home and she has to go back and get it. At what time does she turn around and go back home, and how do you know that's correct? Okay, so let's look at the graph. We have to figure out when, from 0 to 12 minutes, what minute in her travels did she have to double back home?
2,
How do you know it's 2? What makes you say 2, that time 2?
because at time 2 she lost velocity and went back.
So velocity changed signs, right? So when velocity changes signs, or when velocity is 0, what does that represent? What does that represent when velocity is 0?
Stop.
She is stopped, right? She stops. She stopped there. Why did she stop? Because she changed direction, right? She changed direction, right? Before she was going to the right. She stopped at 2. She went left because she had to double back, right? So at time 2 is where she, right? Double back, cover space she already covered. That's where she covers space she already covered. What is she doing from 4 to 5? What? Yeah, she's finding her homework. Yeah, from 4 to 5, she's home. She's not going anywhere. She's at home, but she's trying to find her homework. And then at 5, that's when she picks up where on her trip, right? So let's write this down. Okay. So we're going to say she turned around. Karen turned around at time equals 2 minutes. Because, now what about the graph told us?
You went below 0.
Switch signs, right? Because V of t changed signs. Because if she had hit 0, that just means she stopped. Well, she could stop for a red light She could stop because there's cars crossing. She could stop because she saw a friend. She could stop for any reason. How do we know that she stopped to go back? Because it changed signs, right? Because the graph changed signs. Because she could do this. Where's my... Here we go. Just because she stopped here, how do we know she doubled back home? Because she changed direction, right? Because like here and here, right, she stopped as well. But that's not where she turned around because velocity is not changing signs. It's staying zero, right? So here is where she turned around, because velocity changed signs, okay? All right, last one, letter D. Oops. Okay, so Larry also rides his bike. So Larry's also riding his bike along a straight road from home to school in 12 minutes. So his trip takes the same amount of time, 12 minutes. He's also riding his bike to school. His velocity is given by the function w of t. So now we have, hers is the graph. His rate, how do we know it's a rate? It's velocity. Velocity is a rate. Is given by w of t. So it's kind of like the ones we've been doing, where they give you w of t, r of t, s of t, all those things, okay? W of t is miles per minute for 0 to 12. Who lives closer to the house, Karen or Larry? How do we know? So before we get to calculus, how will we know who lives closer? What's going to tell us who lives closer? Distance, right? Whether the total distance is more or less. So that's what we have to find, right? So when it says who lives closer to the school, we got to find total distance, right? Total distance. So let's start with Larry. You can start with Karen or Larry, but we'll start with Larry since Larry was new. We don't know. And they give us, we've done this before, right? So how do I find, let's see, so let me title this total distance for Larry. So how do I find total distance for Larry? What am I going to do?
You would write it as you figure out the equation.
So remember, I erased them because I needed a board for something else, but,
Figure it out.
right? So where are we at? Are we at the total? Are we at the rate? Or the rate of the rate?
Not the derivative for the rate.
We're at the rate, right? And I need to find the total. So what do I got to do?
The antiderivative.
There you go. I got to do integral antiderivative, right? I got to do an antiderivative for him. So from 0 to what? 12 for w of t. Okay. Go to my calculator. Use your calculator to figure out what is the area from 0 to 12. You should get 1.6. Okay. So Larry's total trip was 1.6 miles. Okay. How do we find total distance for Karen?
Looking at the graph.
Look at the graph. Yeah, Ezekiel, what were you going to say?
Didn't we already find it?
Yeah, what did we find? We found something, right?
We found the absolute value, but not the actual.
Yeah, that's the tricky part, right? First time I did this, I'm like, oh yeah, 1.8. We did it, right? That's total. but why is it not 1.8 for Karen total from her distance from home to school? Why is this one slightly off?
Because she stopped and because she went back home.
Yeah, she doubled back a little bit, right? So her total distance was 1.8. But if she didn't forget her calculus homework, she wouldn't have had to have gone 1.8, right? So how can we use the graph to figure out, in other words, we're trying to ask for her displacement. I'm trying to ask for her displacement. That's her total, right? But she doubled back. What if she didn't need to double back? What's her displacement? How do I figure that out?
Look for the areas of push.
Kinda. What am I going to subtract?
Areas that are negative.
There you go. This is where we take into account the negative. So for this one, see how these two are exactly the same? Except one's positive, one's negative? That's where she doubled back. She went 0.2, and she's like, oh, forgot my homework. So then she went back 0.2, right? Well, for total distance, we added those together. But for displacement, it's just 0.2, right? So for this one is where we're going to consider this guy a negative. That's what we're going to subtract. We're going to subtract that. So we're going to take 1.8 minus her doubling back.
What about the from 4 to 5?
Doesn't matter, right? 'Cause she didn't travel.
Yeah, she didn't go anywhere there, so she didn't go anywhere. So
It doesn't.
for the total, it doesn't matter? Yeah. Okay. Okay, so
Since she spent a whole minute doing nothing and not writing, then the trip from her house wouldn't be 12 minutes.
yeah, it would affected her time. Affected her time, but not the distance, right? So it did affect her time. So she should have gotten to school faster than Larry did. It shouldn't have taken her 12 minutes to go, right? How long should it have taken her? Take away this, right? So it should have taken her, yeah, 9 minutes. Oh, no, wait. Because she didn't slow down, right?
You don't start till 5.
Yeah.
You just do 5 to 12.
There you go, yeah. From 5 to 12, yeah. So it should have taken her 7 minutes, right? That's time. They didn't ask us about time, they asked us about distance, like how far was she, right? So again, like you guys said, right? Where does she actually start? Where should we start counting her total, her distance from school to work, or school to from home to school? Minute 5, yeah. Because all this stuff before was, oh wait, I forgot. Right? Now I'm ready. At time 5, she's actually ready. So really, her displacement is only from 5 to 12. It took her 7 minutes, right? And that part right there, I think is 1.4, right? Double check my math, it's 1.4? Yeah, it's 1.4, right? So yeah, right? She's going, she forgets, doubles back, gets her homework, she's ready to go. So at 5, that's when she actually starts, right? So it's 1.4 miles, yeah. So let's see. Total traveled, total distance traveled, right? Minus 0.4 equals 1.4 miles, right? So judging by that, Karen lives closer. So Karen lives closer.
Would they ever give us a question where we have to figure out who lives closer, but it like takes them different amounts of minutes?
Oh, so they're going different rates? Could be. Yeah.
How do we
Yeah, because we don't know what their rate is. We don't, or no, scratch that. We do know, we could figure out their rates, right? No, usually, so great question. So usually the time when they want to know about rates, it's going to be a derivative question like we did last semester. This unit, they want to know about totals. Yeah. So actually, the answer to your question, we did that last semester. That's what we did last semester when we asked about rates. You could ask about rates, but this semester they usually stick to totals. Yeah. Okay. Because yeah, if we want to know anything about their rates, like who is going faster, if we wanted to know about who was going faster, right? We would use the graph and we would use Larry's rate, right?
No, the thing is like, would they ever ask a question that's like, it takes Larry like 10 minutes to get to school, and then here's his graph, but it takes Karen like 8 minutes to get to school?
Who was going faster? Oh, no, they won't do that, yeah. They might say who's going faster. Well, that's easy. You just divide this by however long it took her to get to school, 7. You divide this by 12, who was going fast. You know, you could do it that way. But yeah, they won't ask that yet. Yeah, they won't. Okay. All right. Okay, so tomorrow, or right now if you want to, you can start practice 13. Okay.